Hello everyone, welcome to this video where we are given a diagram in a coordinate plane, and therefore the coordinates of ABC is given as well. Part A, calculate the area of this triangle ABC. Well, if I am going to use this as my base, which will be 3 units, then my height, I will have to use this height here. 1, 2, 3, 4. 4 units for the height. And therefore for part A, which I'm going to write out here, the area of triangle ABC is therefore equals to half times base times height. Six units square. Find the length AC. Okay. Well, to find the length of AC, put actually C. I'm going to just cut this out so that it's easier for us to see. Okay, that I cut out the triangle. And I'm going to just shift it to the other side so that we could use this triangle for our next part of this problem, which is the part B. Well, let's do the part B here. And I'm not going to use AB now. I'm going to focus on this right angle triangle, where I have 1 unit, 2 unit, 3, 4, 5, and 6. So you should see this right angle triangle here. And therefore I am going to tap on my knowledge for Pythagoras theorem to get my AC easily. And so AC square is simply equals to 4 square plus 6 square. So my AC, and that will be equals to 52. So my AC is simply the square root of 52. And that will give me a value of 7.21111. So 5 significant figures followed by 3 significant figures. .21. Yep. Now, for part C, the perpendicular distance of B to AC. So for this, I'm going to go back to the question again. So what are they trying to find? They want us to find this particular distance here. From B to AC, 90 degrees, which I'm going to draw a red color line now. Or dotted line. So this I'm going to name it as my X. Do take note, we actually know the area of this triangle. Meaning, if I'm going to use AC as my base, then my height will be this x. Do you see that? So for part C, right, we will need to tap on our knowledge that the area is 6 units square. So for part C, I'm going to write it at the side here. Okay. First of all, we do need to let people know what is x. So we are going to let the perpendicular distance of B, or from B to AC be x, so that we could have this half time base AC, which we have gotten from part B. And notice I'm going to use square root 52 and my x. And this equal to the same area because the area never changed. It is still the area of the triangle ABC, 6 units square. And from here, I will then be able to get my x easily because x is simply 6 over my half and over my square root 52 to give me the answer of 1.664. 1 to 5 significant figure followed by 1.66 units to 3SF. So for this part C, right, we are actually using the answer from part A. This is from part A. And this, the length of AC is from part B. To solve, yeah? Alright, let's proceed to part D, where we are required to find the sine of BAC. Okay. BAC. So for this question, right, I am going to do a quick erase of this whole diagram now, so that it's easier for us to see. Oops. Great. For part D, sine of angle BAC, which is this angle here, this acute angle here. And we do need a right angle triangle, yeah? So for this question, it will be good for us to see this particular right angle triangle. Then I can get the sine very easily, because then I would have my opposite side here and my hypo here, because tuakaso. To find the sine, I need my O and my H. And I know that this will be 1 unit, 2 unit, 3 unit, 4 units here. And my hypo, from part B, we have gotten it to be square root 52. And so, for my part D, then I shall write it at the side. With this, I'm going to just take a and just move it across, so that we can use this for my part D answer. So for part D, right, sine of angle BAC equals to opposite 4 over my hypo, square root 52. And this will be equals to 0.5547 to 5 significant figures followed by 3 significant figures. And the last part, cosine of this angle ABC. So for this particular question, then again I will need to erase here and first of all, of course, to highlight this angle first for everybody to see, the first thing we saw that this is actually an obtuse angle. Okay, so rightfully I would want to have a supplementary acute angle for us to work with. And so very seamlessly, we would again extend this out so that we can have this right angle triangle forming. And we all know there's a special relationship for the cosine ratios of the acute and obtuse angle when they are supplementary. They add up to 180 degrees, yeah? So the cosine of this angle ABC, which is the obtuse angle, will be equals to the negative of the cosine ratio of that acute angle. Alright, so for this particular question, I'm going to name this point as D. Okay? And because we are dealing with cosine, so I would then need my length BD, which is 1, 2, 3 units, and my BC, which would then require us to find the length of BC. Okay, and again I'm going to tap on my knowledge of Pythagoras theorem. 1, 2, 3, 4. So I'm going to now cut away this triangle out so that we can use it for, and put it at the side. Our last part. Okay, so this will be our part E. So a recap, to find cosine of this obtuse angle ABC, our job then is to find the negative of the cosine of this angle CBD, the blue color angle. Okay, and in order to find the cosine of the acute angle, we do need the length BC, right? So BC will be BC square is equals to 3 square plus 4 square by Pythagoras theorem. So I can get my BC pretty straightforward. It's 5 units. So for this particular question, when I use my tua castle at the side, and I'm looking at cosine, I'm looking at the adjacent side and my hypo a over h. Do remember that cosine of the obtuse angle is a negative, in this case 3 over 5. And with that, we have come to the end of this particular video of this problem, which I have to admit is pretty long with 5 parts. Yeah. And thank you for spending the time to watch this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day.